Hi students, welcome back to geology. This is our final video in learning about volcanoes and igneous rocks. So now we are focused on rocks specifically. Igneous rocks, how do we name them? So your pondering question is, how do geologists identify and name igneous rocks? You, throughout this lecture and then through your lab this week, you are going to learn how to identify an igneous rock and its origin. So first things first, as we've been talking about several times, that these rocks are formed from magma and lava. Okay, all igneous rocks form deep in the earth, and some come out of volcanoes, and some crystallize in those plutons that we talked about in the last video. We use texture and composition to identify igneous rocks. First things first is texture. This is the size and shape of the arrangement of grains or other constituents within a rock. This is not the rock feels smooth. Okay, so it's not that kind of texture. The texture refers to, as I mentioned, the size and shape of the grains. Okay, so this is mainly controlled by cooling rate. So if we get really large crystals, that means it cooled slowly over time. If we get really small crystals, that means that it cooled really quickly. So we have intrusive and extrusive igneous rocks, or volcanic and plutonic igneous rocks. Extrusive igneous rocks cool quickly at or near the Earth's surface and are usually fine-grained, which means they have really small crystals. Intrusive igneous rocks cool slowly deep inside Earth, and they generally have a coarse-grained texture, which means that the crystals are large. All right, so to kind of give us a warm-up, take a look at these two photos. Pause the video if you need. Can you see all of the crystals? Are they different? Can you see crystals in some but not another? Or can you not see crystals in any of them? Right, so pause the video if you need to, otherwise we will move on. So in the upper left there, you should not be able to see any crystals. It just looks like a black rock. But on the right-hand side there, you can see variation in color, and you can see the large crystals crystallized in it. So the one on the left is basalt, and the one on the right is granite. Okay, so practicing understanding what is a crystal and what it looks like in a rock versus what is not is going to be really helpful for you in identifying igneous rocks. All right, so let's start with intrusive or plutonic igneous rocks. This is when magma cools or hardens inside the earth, which is why we call it intrusive igneous rocks, or sometimes they're referred to as plutonic igneous rocks because they form in a pluton. So we can see all of the crystals with the naked eye. There's some pointed out there for you, a couple of different feldspars. There's also quartz and biotite in this sample. And then if we look at it in microscope, the yellow circle over there shows you what a microscopic view of that rock would look like. The minerals get even larger, okay? So we can see all of the crystals in an igneous, intrusive, or plutonic rock. In our extrusive or volcanic igneous rocks, we cannot see all of the crystals because they cool so quickly that they don't form really large structures. And so in a hand specimen, you wouldn't necessarily see all of the crystals, but if you look at the microscope view, which is the yellow circle again, you can see that there are crystals in there. They're just not nearly as big as the intrusive or plutonic igneous rocks. Okay, so this would be fine-grained, and our intrusive plutonic igneous rocks are coarse-grained. Now, within that, we have some other textures to talk about, like porphyritic. So porphyritic means that there's two distinct crystal sizes. Okay, in a fine-grained porphyritic, we have visible crystals and non-visible crystals. So the visible crystals here are those black, kind of tabular, rectangular-looking pieces. And the crystals that are not visible is that gray matrix holding together those visible minerals. So the fine-grained porphyritic texture forms two different crystal sizes, one you can see and one you cannot. With coarse-grained porphyritic, there's still two different crystal sizes, but they're both visible. Okay, so you can see the larger crystals there that are pink, and then the black and white that are a little bit smaller. So there's two crystal sizes, but you can see both of them in a coarse-grained porphyritic. So this just means that there was differential cooling rates in the magma chamber as this pluton came to the surface. But what about the fine-grained, right? There's some that you can see and some that you can't see. So how do you explain that? So let's take a look at what happens inside of a magma chamber below a volcano. So prior to the evacuation of the material, some of the crystals in the magma chamber crystallize or start crystallizing before it's even evacuated. So we'll see those large black tabular minerals in that rock in that last couple photos that are crystallizing in the magma chamber, and then that gray matrix would crystallize on the outside of the volcano once it erupts. Another texture is glassy texture. So this is commonly from very, very rapid cooling. Because the cooling takes place so fast, no crystals form, and you're really just looking at volcanic glass. So an example of this would be like obsidian. Obsidian is what what Native Americans would have used for arrowheads and hunting. So this is a really sharp-edged rock, and you can make it even sharper by sculpting it into an arrowhead. Another texture is vesicular texture. This is formed from bubbles or gases, essentially, in the magma. So in the magma or the lava, there's a bunch of gases. We talked about the volatiles that would be in a melt. And if those remain after the eruption and then escape after the material crystallizes and cools, you get these basically fossilized bubbles, which are a bunch of holes in the rock. So an example here would be like pumice, which a lot of people use on their feet. But if you look at a microscopic view of it, it's technically glass. It's just really, really small glass with a bunch of holes in it. Another texture term is pyroclastic. Pyroclastic is very heavy in ash. So ash, rock fragments, depending on whether it's all ash or it has ash and fragments in it, we call it two different things. If it has fragments, we call it breccia. If it's mostly just ash and maybe a few crystals, we call that a tuff. Okay. So I want you to pause the video and see if you can assign some texture terms, maybe some crystals you might see, and then consider whether you think the rock is mafic or felsic. Remember that mafic is dark in color. It has high magnesium and iron, and felsic has low magnesium and iron, high silica and oxygen. And the felsic rocks are going to be lighter in color, and the mafic rocks are going to be darker in color. So pause the video, see if you can do some work here. We'll work with these rocks in the lab as well. So the Bowen's reaction series, we've looked at already once with minerals, but we're bringing it back. This is where minerals are crystallizing out of a magma. Norman Bowen developed this after he was studying igneous rocks. He noticed that certain minerals under certain conditions would crystallize or melt faster than others. So he ran some experiments to look at the differences and created what we call today the Bowen's reaction series. Okay, and this shows us that depending on the temperature, we're going to see different crystals crystallizing and or melting. So I mentioned this in one of the other videos that at the top there we have olivine. It melts or crystallizes, at the highest temperature. It also melts at the highest temperature. And then as we move down the Bowen's reaction series, we get to the lowest temperature crystallization, which would be quartz, muscovite, potassium feldspar, those types of minerals. And it also changes what igneous rock type we're looking at. Are we looking at something that's more granitic or more basaltic? Depends on the arrangement or the assemblage of the minerals present. Okay, so this is a good indication of how crystallization takes place and in what order for which types of minerals you're going to see. All right, and some final thoughts here. Igneous rocks exhibit textures like coarse grain, fine grain, vesicular, pyroclastic, and porphyritic. And in your notes, I want you to write down how you can classify an igneous rock, what is one way to do so, and then in the lab, we're going to practice how to identify them. I will see you guys later. Bye.